Hey everyone, Nitesh this side. Hope you're doing good. So let's start with the question. So the question is counted sorted vowel strings. Okay. So you're given an integer n and you have to return the number of strings of length n that consist only of vowels. So you have like in vowels we have a, e, I, o, u. And our lexicographical sorted. Our string x is lexicography sorted if all valid I to SI is the same or come before SI. Basically, it means like let's say if you pick, you can see like by this example, you have picked A. Now next, the second time you pick E. Okay, so the previous character like A is before that, so you don't have to pick the second character again. Basically, it's like after I, you don't have to pick E to the second position. Okay, so what is given to you? You have given a n, and you have to make like you have to return all the valid lexicographical sorted string. Okay, you don't have to basically print the list. You just have to give the size of that list basically. Okay, so as you can see this, let's see the example 2. We have n equal to 2 and our output is 15 because we have like the combination is a, like we pick a, and in this case we can pick the same character again. Like in the previous question that we done yesterday, like combination sum 3, there we can't take the same character or the integer. Here we can take it, but also the condition is also true. By the next time when you pick e, you can't pick a again. Okay, so this question is pretty similar to the previous question, so let's implement it. If you don't watch, like if you haven't watched the previous video, you can check that out. Okay, so what we need will basically, okay, so we'll take a list of string and it will be list. So we'll use the same approach as we use in the previous question. Array list. Okay, let me, so what we have to take, we'll call the solve function, we'll pass n. Okay, and what we will give to them, we will give them a start position and we will also give them a string. Okay, so let's take a string builder. Okay, and let me create a vowel array. Okay, so this will be a, then we have e, then we have I, then we have o, sorry, then we have u. Okay, after that we just return the list size. Okay, so let's write down this solve function. So void solve and start, and let me take a string builder or builder. Okay, so we'll use the same code or the same approach that we use. Like in backtracking, we generally follow the same approach. So for int I will start from start, then I should less than array dot length. Basically you only have 5 possible options, so either you can take array dot length or you can just write I less than equal to 5, I plus plus, and what you will do, you will insert it in the builder dot append. You will push this current character, so array of I, and you will call your solve, and you will reduce your n, like you fix one position, you will skip it, then you will increment your start. But like in the previous question, we do I plus 1. Okay, in this we don't have to do I plus 1 because we can take the same character. As you can see, a can be possible, e can be possible, so we'll take I only and we'll pass the builder. Okay, after this the backtracking step, remove that builder dot delete char at. Okay, so it will be builder dot length minus 1. Cool. I think we have covered the recursion, so let's just write the base case. If our n is equal to 0, what you have to do, you have to insert it into the list. Builder dot to string. After that you just return. Yeah, I think we have done with the code, so let's run it. Okay, let's see. So as you can see, this is accepted. Let's submit it. Yeah, so our code is submitted, but you can see like it taking like larger time, we can optimize it basically. So if you calculate a time complexity for this, so what we have, like we have a n length of string that we need to find out, and at every position we have a basically, you can say, 5 combination. So it's like 5 cn. Okay, so you have to make a combination of at every length, so we can optimize it. Okay, so let's see how we can optimize it. Okay, so let's see. So what we have a array of vowels which is having a, e, I, o, u. Okay, these are the 5 combination that we have to take. Okay, so let's say, so this, let's assume its length is k. Okay, so, and if we like, it's always be like, if you take a, then you can take this. Okay, so you have a, e, a, I, basically a, o, and a, u. Okay, now if you take e, you will take after the character of this, so you will take only this. So with e you have, and I skip one, so you can take the same also. So e, a, then you here you can take e, 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 I, e, o, and e, u. Similarly for I also, so it's like I, and I, o, so I, u. Okay, so if we can say, if our k is 1, okay, so then we only have a possible, like we can, like right now we have k is equal to 5. So k is, if k equal to 5, it's pretty simple. It will be like a, e, I, o, u. Okay, and your n is 1 for all these cases. Let's say our k equal to 1. So we only have this option, because after this we can't take. So we have this u. Let's say k equal to 2. So we have o, u. If 3, it will be I, then o, then u. If we have 4, then we have e, I, o, u. Okay, so what we can use, like by the use of this, we can create a 2D matrix. Okay, so let me just create a 2D. So let's do it like this. This will be our k, 0, 1, 2, 3. Okay, let's take this as, this will be our n, and this will be our number of character. Okay, so it will be 0, 1, 2, 3, 4, 5. Okay, so let's assume we have given a question equal to n equal to 3. Okay, let me just do it. Yeah, okay, so now what we have to do, and if you can see, for 1 we have one option, we'll take this. For 2 we have 2 options, so o, u. For 3 we have I, comma, o, comma, u. Similarly for 4 we have e, comma, I, then o, comma, u. And here 5, a, e, I, o, u. Okay, so let's fill the value in the matrix. Okay, so for the initial, like if n is equal to, like your number of characters is also 0 and your n is also 0, so there will be no any possible output, so you will fill 0 by this. So you will fill 0. Let's change the color. Okay, so you will fill 0, 0, 0. Here also 0. Now let's fill it here. Okay, so we have one option. Okay, and I'm not saying like for the one you only have u. You can take, like out of the 5 option you can only take one. Currently I'm taking u only. Okay, so after this, like at n equal to 1. Okay, okay, I think I have done one, like I speak one thing wrong. So like we need to maintain the sorting, that's why we are taking this ordering. Okay, so that's why, as you can see in the last, we have sorted order. So let's fill this. Okay, so for the one index we have u. Okay, we have one position and we have one element, so we'll fill it by 1. Okay, now at this position our n is 1, and now we have 2 characters, so that means we have 2 options. Either we can use o, and either we can use u. Okay, so we have 2 options. Now at n is also 1, similarly we have 3 options, so let's fill 3. This is for 4 and this is 5. Okay, Now let's fill this n equal to 2. Okay, so when n equal to 2, okay, so when our n equal to 2, we only have one option for this, like we have u character, but we can take u, so this will be one output. So for this case we have only one. Okay, now let's see for this. For 2 we have two characters, and let's see how many possible combination we have. So we have ou, so we can take oo together, we can take ou, and we can take uu. So we have three possible combinations, so we can take 3. And as you can see, all are in the sorted. We are like, we can't take uo, this will not be a possible. Now let's see for this. Okay, and if you can see how 3 is coming also, you can basically do the sum from this and this. Okay, if you do the sum for this, you will get this value. Okay, let's do the sum for this, and let's see, it will be 6. Okay, so let's also find out the 6 combination. So we have I comma, let's verify whether it is giving 6 or not. We have n equal to 2, so we have I, then we can take o. Okay, then we can take oo. We can take one more thing, we can take izu, and we have oo, then we have ou, and then we have only uu. So we have 6 combinations. As you can see, this is the, so as now I think you got the like approach how we will do it. So what we will do, we will do the sum for every this index, and finally we will get the output at this index. Okay, so if we calculate a time complexity for this, so we just creating our dp, so it's of, you can say, 5 cross n. This is the time complexity, which like earlier it was 5 combination 5 factorial n, but here now it's 5 into n. Okay, so let's write the code for this. So let me just reset it. Okay, so what we need, we will create a dp new int, we'll take a n plus 1 and we'll take a 6. Okay, so let's just fill it from 1 to n plus 1 I plus plus for int j equal to 1 j less than 6 j plus plus. So it will be like dp of ij is always be dp of I minus 1 j plus dp of I j minus 1. Okay, and finally we just need to return dp of dp of basically n comma 5. Okay, now there will be one condition which we need to add. So as you can see, for this line, okay, this all have 0. This we have, like, we created a dp size, so it's already 0. We need to just initialize this line also. Okay, so how we will initialize it, basically for this case we will not, like, if we do 0 plus 0, it will always give us 0, and for the final it always have the 0 output. So we need to fill this value, then we can get the final output that we want. So how we will fill it, we will just basically start calculate for this. We will do for the just do 0 plus 1. Okay, so you will get 1. So you just have to check the previous column and do plus 1. Okay, so 1 plus 1 is 2, 2 plus 1 is 3, so it's like we will fill it. Okay, so what we will do, if I equal to 1, we just have to do dp of I j equal to 1 plus dp of I j minus 1, else you have to fill like this. Okay, yeah, let's run it. Okay, so oh, it's a 2D. Let's run it. So this is accepted. Let's submit it. Okay, now you can see, compare, like, runtime is 1 millisecond and memory is also less. Okay, so that time complexity is 5 into n, and space is also, we are creating a extra, you can say, a 2D matrix, so that is also 5 into n. Hope you like it. Thank you for watching video, and do join the Telegram group if you have any doubt, any concern. Thank you.